pressure head. Imagine that I have a pressurized tank right here full of water. So the pressurized tank, and then I have a plastic tube to kind of see how much pressure we got inside. This is the pressurized tank full of water. So water everywhere, water. See, if the tank is pressurized, the water will go up and it will go some level, depends on how much pressure do I have. Assume that this is H, the height, that the pressure amount of equivalent pressure. This piece is called pressure head. And let me explain why this is called pressure head. And assume that I'm interested in pressure in this tank at this point right here. Now, if I want to measure pressure on that cross section, I can simply write pressure is equal to force by area. Now, force in this case, the amount of water on this tube. So that the force I will feel if I put my hand in there, it will feel the amount of water I have there. So we can simply write, instead of force, we can replace that with weight divided by area. Now, what I can do also, let's multiply both denominator and numerator by the h. So then let me separate the weight divided by the area times height. Now, area times height for a cylinder is the volume. So you can say weight per volume, which is the specific weight of the fluid. So we know from the basics that weight per volume is the specific weight, pound per feet cube or Newton per meter cube, things like that. So in this case is the specific weight of the water, and which is the fluid physical properties. For example, water is specific weight. If I fill a box with 1 feet in all sides, so that's 1 feet cube volume, I fill this thing with water, it will weigh 62.4 pounds. So water specific gravity is 62.4 pound per feet cube. This is a fluid property. So we can measure pressure by the fluid property, specific weight, times the height of that. So that's why this is called pressure head. A lot of times you hear about something like 30 inches of mercury, for example. So 30 inches of mercury. So this is what they're talking about, is a similar situation. So if you set up a mercury tube like that and fill this bath with mercury, and if this tank is pressurized, let's say, then it's gonna be 30 inches. Let's say it's pressurized up to 30 inches of mercury. In fact, if I just close this and the air is pressurized here, then I'll have 30 inches of air, 30 inches of mercury. That's actually the air pressure. If I convert that to the regular PSI, for example, so I know that P equal to gamma H, in this case is gamma of mercury and the height of mercury. So gamma of mercury is 13.6 times heavier than water. So the mercury gamma, or specific weight, would be 13.6 times 62.4 pound per feet cube times 30 inches. Now I got some messed up unit here. If I convert all of these to pound and inches, I'll get 14.7 pound per square inch psi. So we can express pressure in terms of psi, in terms of Pascal, Newton per meter square, or in terms of the head of the pressure. So for example, 50 inches of water. What that means is the water column will height up to 50 inches, like that. So you can either express that way, one in psi, one in Pascal. And in fact, these inches of liquid is more common in the lab and in actual application than PSI.